Yes, thank you. So I would like to present this resource paper. And this paper deals with the task of learning recommendations from multi-modal user interactions. In many domains, the users can interact with the system through multiple channels, for example, website and call center. And in this case, the user interactions have multiple modalities that cannot easily be combined in traditional recommender systems. So in with this paper, we contribute a recommendation dataset with multi-modal user interactions, as this area is very under-researched. And in addition, we provide a comparison of existing approaches for combining multiple modalities. And finally, we propose a novel approach specifically designed for multi-modal user interactions in recommendation. So the task is to learn recommendations from multi-modal user interactions. And although there exist many examples of interaction modalities like click, speech, social tagging, image posting, and so forth, prior work on multi-modal recommender systems mostly concerns items with multi-modal features. For example, when items are presented with images and textual descriptions. And in the case of multimodal user interactions, the modalities are often missing. For example, if a user only interacts through the website. And this is a problem for the existing methods that typically require all the modalities to be available. Also, in the case of multimodal user interactions, the modalities are missing for natural reasons, like the user chooses not to interact through the call center. And there exist general machine learning methods for dealing with missing modalities, but these methods are designed for scenarios where the modalities are missing for technical reasons, like problems with the measurement. So for that reason, we publish a real-world dataset from an insurance company. And this dataset contains users with purchases of insurance products. And then it contains the users' prior phone conversations in the company's call center and the users' prior sessions on the company's website. So, for example, here a user has had a session with clicks on the website, followed by a phone conversation with speech between an insurance agent and the user, and so forth. And in this dataset, only 19% of the users have had both conversations and web sessions. So the majority of the users has a missing modality. Then we also empirically compare different methods for this multimodal task, including lay fusion, that simply averages the predictions from separate models trained on each of the modalities. We also compare with knowledge distillation that trains a joint model on the subset of users with complete modalities and uses information from separate models. And finally, we compare different imputation strategies that fills the missing modalities with synthetic data. Then we propose a novel approach that is to map the modalities into a common feature space, because in this way, a missing modality will not affect the recommendation model, since once they are in the same space, they can be treated equally. Our experimental results show that the two modalities represent different information that supplement each other well in the recommendation task. And by mapping the modalities into a common feature space, our approach further managed to capture feature interactions between the modalities. And the results also show that a less frequent modality benefits from being modeled together with a more frequent modality. So, thank you for listening, and if you are interested, come hear more at the poster session.